In this video, I will discuss some JEE Main PYQs from the topic Newton laws of motion. These questions have appeared between the years 2025 and 2023. Timestamps are given in the description box. You can watch parts of video if you are running short of time. I will discuss some 8 questions. This is the first one. An object with mass 500 grams moves along x-axis with speed v equal to 4 root x meter per second. The force acting on the object is. You can pause on this question. The object is moving along the x-axis. It's a 1D motion. Velocity is given. Acceleration is rate of change of velocity, that is d by dt of velocity. So this can be written as d by dx of v into dx by dt. So this I can get from here. So x raised to the power half. So half into x raised to the power minus half. And dx by dt is same as v, which is 4 root x. Dx by dt is v. So here, this and this will cancel. So it's 8 SI units. So acceleration is just a number. It's uniform and constant. That means force, which is mass into acceleration, Newton's second law, will also be a constant. Mass is 500 grams, that is half kg, into acceleration is 8. So it's 4 SI units, Newton. Option D. D is the correct answer. So this is what I've done here. Velocity is 4 root x given in the question. Acceleration is rate of change of velocity, which can be written as dv by dx into dx by dt. This is chain rule of derivatives. And dv by dx, if I differentiate this with respect to x, I'll get 4 half x raised to the power minus half. And dx by dt is nothing but the velocity, 4 root x. So it is 8. So it's just a number, which means acceleration is uniform and constant. Force is also uniform and constant because force is nothing but acceleration scaled by a factor mass. And mass is a constant mass. So mass is half kg. So force is 4 Newton. Next question. A body of mass 4 kg experiences two forces, F1, 5I cap, 8J cap, 7K cap, and F2, 3I cap minus 4J cap minus 3K cap. Acceleration acting on the body is. You can pause and rub this question. The body will respond to the net force. So the net force here is sum of the two forces, F1 and F2, and force is a vector. So the sum should be a vector sum. So that will be equal to 5 plus 3, 8 I cap, and then J component is 4, and then K component is 4. So instead of writing I cap, J cap, K cap, and also written right like this. So it's understood that it's 8 I cap, 4 J cap, and 4 K cap. So this is the net force. So acceleration is force by mass. Force is a vector, acceleration is a vector. This is Newton's second law. And mass is 4 kg. So this divided by 4. So 2, 1, 1. 2 I cap, 1 J cap, 1 K cap. C is the correct answer. So this is what I explained here. Acceleration is force by mass and net force is 844, sum of F1 plus F2. And the mass is 4 kg. So answer is 211. Next question. A wooden block initially at rest on ground is pushed by a force which increases linearly with time t. Which of the following curve best describe acceleration of the block with time? So force is given as increases linearly with time. So when time increases, force will increase. So this is equal to some constant, say k into t. And acceleration is force by mass, Newton's second law. So this is nothing but k is a constant, mass is also a constant, mass into t. So acceleration is also proportional to time. So it's not a curve, and acceleration is not constant with time, it's increasing with time. So option E is also out. It's either A or B or C. And acceleration at time t equal to 0 is 0 if force at time t equal to 0 is 0. So here in this question, they shall mention initially the force is 0. Rest is not required. The initial force should be 0. In that case, the correct option is option B. Even at t equal to 0 minus, before this 0 time, the force is 0. So acceleration is 0. So only at t equal to 0, the force starts acting and acceleration will start picking up because force is increasing with time. B is the correct answer. So in the question they are given, initially it's at rest, that is u is 0, but that's not actually required. Force is linearly increasing with time, this is given in the question, and k is a constant. Acceleration is force by mass, Newton's second law. So it's k by m into t. Mass is a constant, mass k is constant. So acceleration is proportional to time. So this is the one. And initially the force is 0. That is at time t equals 0, force is 0. So if that case, option B is the correct one. So instead of saying initially it's at rest, they should have mentioned initially there is no force. Next question. Spherical body of mass 2 kg starting from rest acquires a kinetic energy of 10,000 joules at the end of 5th second. The force acting on the body is. You can pause and attempt this question. So spherical body of mass 2 kg starting from rest acquires kinetic energy. So it start moving. So the end of 5th second means t equal to 5 seconds. First second is between t equal to 0 to t equal to 1. This is the first second. So 5th second will be between t equal to 4 and 5 seconds. So end of 5th second means time is, total time elapsed is 5 seconds. So the energy at this instant is 10,000 joules. And this kinetic energy is half m v square, v at this instant. Mass is 2, so this will cancel. So velocity is 100 SI units meter per second. 2 and m will cancel because m is 2. So v square is 10,000. So v is 100. So at time t equal to 5 seconds, velocity is 100 starting from rest. So acceleration of this motion from 0 to 5 seconds is the increase in velocity, which is 100. minus 0 by the amount of time is 5. So acceleration is 20 SI units meter per second square. Force, Newton's second law, mass into acceleration, mass is 2, SI units Newton. What is the correct answer? So the body is starting from rest at t equal to 0 and the mass of the object is 2 kg. So first second is between 0 and 1. So fifth second is between t equal to 4 to t equal to 5 seconds. That is fifth second. So at the end of fifth second, the kinetic energy is 10,000 given in the question, which is half mv square, and m is 2 kg. So this will go. So v square is 10,000. So v is 100. Acceleration is increasing the velocity from 0 to 100 in the time 5 seconds. So it's 20 SI units meter per second square. Force is mass into acceleration, which is 40 Newton. Next question. Force acts for 20 seconds on a body of mass 20 kg starting from rest, after which force ceases and then the body describes 50 meters in next 10 seconds. The value of the force will be. You can pause and attempt this question. Mass 20 kg. So for 20 seconds, there is a force. Say here T is 0. Here T is 20 seconds. So there is some force in this time interval. And after this, the force is 0. And it continues to move because of the acquired velocity. It will come here. And this distance covered is 50 meters without any force. And the time taken is 10 seconds. So to find the value of this force. Second part, there is no force. So what is the velocity here? It's a uniform velocity. So the velocity at this, in this interval is the distance traveled by the time taken. So the uniform velocity for this second part is distance traveled is 50 meters and the time taken is 10 seconds. So it's 5 meter per second square. So velocity at this point is same throughout here up to here, and this velocity is 5 SI units meter per second. So here the velocity is 0, initial velocity. So this interval, the acceleration is acceleration the first part, increase in velocity 5 minus 0 by the time taken 20. So 1 by 4 SI units. So force is in this interval is mass into acceleration 20 into, so 20 by 4, 5 Newton. Five is the correct answer. So in this motion there are two parts. First part, for 20 seconds there is a force. After that, force ceases to exist. In the second part, it travels a distance of 50 meters given in the question. In the next 10 seconds. In the next 10 seconds. So here the time is 30 seconds. So in this part, since the force is 0, acceleration is 0, so velocity is uniform. So what is the velocity here? The same velocity will move up to this point. So the velocity for this interval is the distance traveled 50 in the amount of time 10. So it's 5 meters per second. So velocity throughout is 5. So at this point it is 5. Starting from u equal to 0. So the first part, the velocity is increasing from u equal to 0 to 5. After that, it's constant 5. So the action is the first part. And the first part is increase in velocity 5 minus 0 and the amount of time is 20 seconds. So it's 5 by 20 meter per second square. Force is mass into acceleration. Mass is 20 kg. So 20 with 20 cancels, 5 Newton. This is the next question. At any instant, the velocity of a particle of mass 500 grams is 2t I cap plus 3t square j cap meter per second. If the force acting on the particle at t equal to 1 second is I cap plus x j cap, then the value of x will be. You can pause and run this question. So velocity as a function of time is given. This is the velocity. So acceleration is rate of change of velocity. Velocity is a vector, acceleration is a vector. This is the velocity vector. So from this the acceleration, the x component will be differential with respect to time, will be 2. J component is 60. There is no k component. It's only I and j cap. So it's 2 I cap plus 60 j cap. So this acceleration is a function of time, and at t equal to 1 second, acceleration at t equal to 1 will be 2, 6 meter per second square. So this meter per second. Force is this into mass. Force at t equal to 1 second. Mass is 500 grams. SI units half kg. So this divided by 2, 1, 3 Newton SI units. And this has to be compared with 1 plus x j cap. So x is 3. Comparing this with the given expression. Option A is the correct answer. So velocity is a function of time. It's given us 2t I cap plus 3t square j cap. Instead of writing I cap and j cap, I can write like this. Acceleration is dv by dt. So I have to differentiate with respect to time, term by term. So this I cap will become 2. This j cap term will become 60. Force is mass into acceleration. Mass is 0.5 kg. So this divided by 2. And at 1 second, and I have to put t equal to 1. So this have to compare with 1, x given in the question. That means x is 3. Correct option is option A. This is the next question. 3 forces F1 10 Newton, F2 8 Newton, F3 6 are acting on the particle of mass 5 kg. The forces F2 and F3 are applied perpendicular so that the particle remains at rest. If F1 force is removed, then the acceleration of the particle is. So on this particle, there are 3 forces, F2 and F3 are perpendicular. So let this be F2, F3. F3 is less than F2. This is 6, this is 8. And since the particle remains at rest when all the 3 forces are there, so F1 should oppose the sum of these two. So F1 will be like this. So F1 plus F2 plus F3 vector is equal to 0 because the particle is remaining at rest. That means the net force is 0. So when F1 is removed, the thing will start moving because net force is not 0. So once F1 is removed, F net is second force and third force. And when all the 3 forces are acting, the particle is at rest. That means F1 plus F2 plus F3 equal to 0. So F2 plus F3 is minus F1. So now the acceleration when it's moving in the second case where the F1 force is removed. So the net force, so acceleration will be the net force minus F1 by mass 5 kg, and F1 is 10 Newton. So it's 2 meter per second square. So only magnitude is required. B is the correct option. So there are 3 forces acting on this body of mass 5 kg, and they are given F2 and F3 perpendicular. When all 3 forces are there, the particle is not moving. That means the net force is 0. That means the F1 plus F2 plus F3 equal to 0. After that, the force F1 is removed. Because of that, the mass will move. So in that second case, the net force is F2 plus F3, and the acceleration is the net force by the mass. And F1 plus F2 plus F3 is 0 because initially the particles at rest. That means the net force is 0. So F2 plus F3 will become minus F1. And F1 is 10 and mass is 5. So acceleration is 2. This is the next question. A body of weight 200 Newton is suspended from a tree branch through a chain of mass 10 kg. The branch pulls the chain by a force equal to if G equal to 10 meter per second square. You can pause and attempt this question. So this is a tree branch. And there is a chain here. And there is a mass whose weight is 200 Newton. And the chain has got a mass. So that will exert a downward force of M into G, where M is 10 in SI units. So if you take this full thing, so at this point on the branch, the full force, this is weight 200 plus this mg, will act here, and there will be a normal reaction between the contact point of the chain and the branch N. So this normal reaction will be equal to the net downward force, which is the weight of this full thing, the block of 200 Newton plus M into G, 10 into G is 10. So this is 300 Newton. So there will be normal reaction of the reaction force of 300 Newtons at the contact between the branch and this chain. So that is the force which the branch pulls the chain. Three hundred is the correct answer. So this is a tree branch. There is a chain of mass 10 kg. So the weight of the chain is 10 kg, and there is a mass attached here of weight 200 Newton. So this full weight 200 plus 10 G will act on this contact point of the branch and the chain, which will pull this branch downwards. There will be normal action in the upward direction. So the total force, downward force, which is pulling this branch is 200 plus this one, which is 300.